So, theoretical study in this theoretical study, we are going to learn how to determine the positions of the centers of bright and dark fringes. And I am going to prove that they are equidistant and so on. So in the theoretical study, I want to start with the optical, with the geometrical and optical path differences and their relation with the positions of the centers of the fringes okay. Suppose you have here medium of index n, okay, and here this is the two small slits S1, S2. This is the laser beam. This is the screen E. This is I, the midpoint of S1, S2, and O is the orthogonal projection of I on the screen. I am going to introduce here a letter A, which represents S1, S2, distance between the two slits. So you have here S1, S2 equal to A. Don't forget, or don't be confused with A in case of diffraction. A in case of diffraction is the width of one slit. Here A is the distance between the two slits. And here this is distance D. The same as in the diffraction pattern, we consider the distance between the screen and the plane of the slit is D. Now, to determine the position of the centers on the screen, I am going to choose an x-axis vertically upward of origin O. Then P, which is in the zone of interference, which represent the center of either bright or dark fringes, will be determined by abscissa X, okay, abscissa X. You have here two rays coming from, one from S1 and the second from S2, okay? This is distance D1 and this is distance D2. We said that the geometrical path is the projection. I make a projection from S1 to D2. This is delta, okay? Now, without a proof, you should know that this delta, the optical path difference from S till P, we prove it to be this delta is equal A times X over D without a proof. فإذا الدلتا which is S2P minus S1P, we can prove it, but you are not responsible about the proof, that delta is equal AX over capital D. Very simple. A times facing it X over D. Okay, this is the geometrical path because in medium N. So geometrical path difference, which represented it by delta. Now, what is the optical path difference? Take care about this. We said that the optical path is the path that corresponds to the geometrical path in vacuum during same time t. So this means I want to change this one to vacuum. And as we said, because the speed of light in vacuum is c larger than v in the medium, the distances covered here should be increased. Yani, if I change this to vacuum, then SS1 will be longer. This is S. This will be longer. Okay? These rays will cover more distance. Also here, this is S1, S2, and here this is the screen, and here this is the x-axis, this is I, O, and this is D, this is P now, this is P. Now, distance now here, S, it covers here, S1P, this is the geometrical path. The corresponding path is S1P, which is longer, S1P prime, okay, which is longer than this one. Also here, S2P is longer than this S2P. Because of this, I am going to call it S2P, all of it prime. So, the optical path difference, in this case, optical path difference. Let's see, what is it equal to? I am going to call it delta prime. So delta, the geometrical path delta, correspond to it optical path difference, delta prime. What is it equal to? Let's see. Now you have S1P prime, okay, this is optical path. Or SS2 minus SS1P prime. Also you can reverse, you can write SS1P minus SS2P. You can do this also because there is difference and you will get minus or a plus according which is larger. Let's decompose this. SS2P is equal SS2 prime, okay, plus S2P prime minus S1 prime plus S1P prime, okay? Now this distance SS2 prime SS1 prime are the same, so these cancel, and so you get S2P prime minus S1P prime, okay? What is this distance here on this figure? I also here take S1 and drop a perpendicular. This will be delta prime, okay? This is delta prime. But now, let's find a relation between delta prime and delta, يعني between the optical path that correspond to the geometrical paths in vacuum, in medium. What is this equal to? This is N S2P, okay? We said at the beginning of the chapter that the optical path is equal N times the geometrical path minus N times S1P. Take N common, so you get S2P minus S1P, which is equal N delta. So the optical path difference is equal N times the geometrical path difference, okay? Now, since we are working in air, if we are working in air, N will be approximately 1, so you get the optical path difference is approximately equal to the geometrical path difference, okay? فإذن also in vacuum 1, so you get delta prime equal delta. So whether we are working in vacuum or in air, the geometrical path is the same as the optical path, and the optical path differences is the same as geometrical path difference. They are the same. I can't distinguish between them, okay? Now I am going to use this relation, and this one to determine the positions of the centers of the bright fringes and dark fringes. So let's start. Positions of the centers of fringes, okay? First, positions of the centers of bright fringes. In vacuum or air, we said that the optical path difference in vacuum or air is the same as the geometrical path difference. So I can write delta which is the same as delta prime equal AX over D. Don't forget X is the abscissa that gives me the positions of the centers of the fringes. If you have a bright fringes, this implies delta must be a whole number of lambda, where k belong to z. Now, delta equal delta gives me, this implies AX over D is equal k lambda. This implies X is equal k d lambda over A, where k equals 0 plus minus 1 plus minus 2, etc. Okay, this should be memorized. Now, as you see, the positions depend on D and on lambda and on A. Okay? If D increases or lambda increases, X increases. Distance between the centers from O increases. Look here, X to A are inversely proportional. If A increases, X decreases. The fringes becomes nearer to each other, and vice versa. Now let's indicate some bright fringes on the screen. Okay, so this is the screen. This is O. This is I. This is S1, S2, and here this is the laser beam. Okay? Now, look at this formula. If k equals 0, this means X equal to 0. This gives me K0 is the order of the central bright fringe. Central bright fringe. Okay? If I take K plus or minus 2, at the center, at O, you have central bright fringe. This is the center of the central bright fringe. You have here order 0. هيدي اسمها central bright fringe. Okay? If we take K plus or minus 1, K equal plus minus 1, this implies X, put the plus minus 1 here. You get plus minus D lambda over A. K1 plus minus 1, this is first order bright fringe. فإذا first bright fringe. K plus minus 1 first bright fringe. This means the abscissa plus D lambda over A, which means that I should move from O distance D lambda over A. The order تاعها plus 1 gives you first bright fringe. Okay? Similarly, minus, there is symmetry here, as you see. And here K equal minus 1, also first a bright fringe. Okay? k plus minus 2. Similarly, k equal plus minus 2, يعني x equal plus minus 2d lambda over a. This gives me second bright fringe. So 2d lambda over a. يعني this is d lambda over a. I should move equal distance. This will be k equal plus 2 second bright fringe. Also here symmetry to it. So you get here k equal minus 2 second bright fringe. Let me take one more, and k equal plus minus 3. This x equal plus minus 3d lambda over a, third bright fringe. So you move also equal distance to this, and you get here k equal plus 3, third bright fringe. Similarly, you move down below O, k equal minus 3. Also here you have third bright fringe. Okay? As you see, the fringes are symmetric with respect to O. Okay? Right. This is in vacuum or in air. If I go to a medium, in a medium, we said that the geometrical path that corresponds to geometrical path difference, the optical path difference that corresponds to the geometrical path difference is given by delta prime equal n delta, and you can't write delta prime equal to delta as we have proved. So يعني equal NAX over D. If I talk here bright fringes, this implies delta prime is equal k lambda. يعني NAX over D is equal k lambda. This implies x equal kd lambda over NA, where k is equal 0 plus minus 1 plus minus 2, etc. So the formula becomes like this. Okay? If I want to compare it with this in vacuum or air, you will notice, to distinguish between the two, I am going to call this x prime, okay? If I want to compare, if you want to don't to compare, you can leave it x. But because I want to compare, I put this x1 and this is x. What do you notice here? You notice that x, this is what? This is x, okay? So compare, you will notice that x prime is equal x over n. But n is what? Greater than 1. So this means that x prime less than x. What does this mean? This means that the fringes become closer to O, because the abscissa, for example, was here 1 milli, it will become 0.75 milli, okay? And so on. Right. This was about positions of the centers of the bright fringes. Also, you can derive this formula before I talk about dark fringes. You can derive this formula in a second way. Notice here, okay? Notice, or note. Look here. In vacuum, الأبسسة was X, okay? In a medium, the abscissa was X. When I change it to the optical path, it becomes X prime. Okay? Also, this is due to what? K is constant, D is constant, A is what? Is constant. So lambda changes from medium to what correspond to it in vacuum changes. So I can write here lambda becomes what? Lambda prime. Will X becomes شو? X prime. K U D U A remain constant. يعني the formula becomes X prime equal K D lambda prime over شو? Over A. But as you know, as we studied previously, lambda بتساوي lambda in vacuum over lambda prime in the medium. This should be proved, we said. يعني this implies lambda prime equal lambda over n. Okay, substitute here in this formula. What do you get? You get X prime equal KD lambda over n over A, which gives you KD lambda over NA, okay, which is the same as this one, as that one. It is the same where K belongs to Z. Don't forget the K. How to find the positions of dark fringes? Positions of the centers of the dark fringes. So I'm going to change here bright fringes and write dark fringes, okay? Dark fringes. In vacuum or air, whether I am talking about bright fringes or dark fringes, the optical path difference remains equal to AX over D in vacuum or air. Okay? But here, bright fringes, I want dark fringes instead of bright fringes. What is the formula? The formula is delta equal 2K prime plus 1 lambda over 2, where K prime belongs to Z. Okay? What does this give me? So, delta equal delta, I write AX over D equal 2K prime plus 1 lambda over 2. And cross multiply, you will find X equal 2K prime plus D lambda over 2A, where K prime also equals 0, plus minus 1, plus minus 2, etc. So this is X of the dark fringes, okay? Also, let's indicate some positions here. I'm going to write if K prime equal to 0, let's see what will be the position. Substitute K prime 0, this will cancel, you get D lambda over 2A. So X is equal D lambda over 2A. d lambda over A. What is this? This is the first dark fringe, okay? First dark fringe. Let's indicate it there. As we said, this is d lambda over A. This is d lambda over 2A. So it is at the center of the first dark fringe, is the midpoint of this segment. So K prime equals 0 gives you first dark fringe, okay? Right. There is also a first dark fringe between these two centers because the interference pattern is symmetric with respect to O. So this is K prime. But what is its order? Okay, let's see. If I put K prime equal minus 1 here, K prime equal minus 1, what do you get? You get X equal minus 2 plus 1 d lambda over 2A, which gives you minus d lambda over 2A. So also here, this is the symmetric dark fringe, but the orders here are different. Not like that of the bright fringes. The bright fringes, you have the one above has K plus 1 and the one below has K minus 1, okay? Whereas here for dark fringes, the first one above has K prime 0 and the second first dark fringe below has K minus 1. Okay, so first dark fringe. There is no symmetry in the order like the bright fringes. You should take care about this. Type. Let's take the second one. If K prime equal 1, then X equal, substitute 1, you get 2 plus 1 is 3 d lambda over 2A. If this is, this means if this is d lambda over A plus d lambda over 2A, you get the center of the second dark fringe of order K prime equal 1. So this is second dark fringe. Also there is one here. What is its order? This is of order 1. Okay, what is the order of this? The order of this, let's see, I am going to put minus 2. So put minus 2, you get minus 4 plus 1 minus 3. So you get X equal minus 3 d lambda over 2A. So here you have second dark fringe. Okay? One more. If K prime equal to, you get X equal 5 d lambda over 2A. What corresponds to this below O? K prime equal minus 3. So you get here X equal minus 5 d lambda over 2A, and this gives you the third dark fringe. Okay? So this one K prime equal plus 2 gives you third dark fringe, and this one K prime equal, sorry هون كان عندنا K minus 2, this is second dark fringe. Okay, I forget to indicate it before, now I have indicated it, and you have here K prime equal minus 3, this is the third dark fringe. Okay, so in case of dark fringes, you should distinguish between the order and the name of the fringe. Okay? There is no problem in the bright fringes. There is no problem between the order and the name of the fringe. But here we have a problem with the positive case, okay, that you should take care about. Look at K prime. When we say K prime minus 1, minus 2, minus 3, etc., there is no difference here between the order and the naming. يعني K prime minus 1 is first dark. Okay, first dark fringe. This is second. K minus 2 second, K minus 3 third, K minus 10 يعني 10th, but below O. Let's see the positive values of K in this case. Look carefully. K prime 0, 1, 2, 3. 0 here corresponds to what? To first dark. This one corresponds to second dark, third dark, and here fourth dark. Fourth dark. What does this mean? This means that there is difference of 1 between the order and the name of the fringe. Okay? يعني if the order, this is K prime order, this is name. Okay? From order to name, I should add 1 plus 1. يعني if I say K0, name is first dark. Okay, K1 name second dark, and so on. If I say K9, name will be 10th dark fringe. Okay, now the reverse. If I say 9th dark fringe, then K prime is 8. Okay, so from the order to the name, I should add 1 for the name. From the name, if I have the name and I want the order, I should remove minus 1. Okay? This is very important note that you should take care about. Now, suppose you have in a medium of index 1, what are the positions of the dark fringes? I am going to use the second method in order to find the positions of the dark fringes in a medium. Okay? فإذن هون in a medium يعني if the Young's double slit experiment with 2 slits and the screen laser beam, if I immerse this system in water, for example, and I do it in water, what happens to the positions of the dark fringes? Notice here, D wouldn't change because distance between the slit and the screen also width the distance between the two slits. What it changes is lambda. So lambda becomes what? Lambda prime equal lambda over n. Lambda decreases, so x decreases. X becomes what? X prime. So the position of the dark fringes will keep the same form but replacing lambda by lambda prime. So this implies x prime equal 2k prime plus 1 d lambda prime over 2a. Replace lambda prime by lambda over n. What do you get? Yani, this implies x prime equal 2k prime plus 1 d lambda over n over 2a gives you 2k prime plus 1 d lambda over n 2a. Okay? K prime belong to Z. So, if you notice here, 2k prime plus 1 d lambda over 2a is what? Is x. 2k prime plus 1 d lambda over 2a is x. Okay? So, this is x in vacuum or in air. This is x. So you get here x prime is equal x over n, the same result as that of bright fringes. And this what should you expect. Why? Because between two consecutive bright fringes there is a dark fringe. So if bright fringes become closer, the distance between the center and the midpoint here becomes closer. Okay? This gives you the positions of the centers of the bright fringe. Now, this is theoretical study. Let's see how this theoretical study fits with the experimental results. Okay? First, if you look here, this distance is what? D lambda over A, okay? Also, this distance is D lambda over A. This distance, as you see, what does this mean? This means that they are equidistant. The centers of the bright fringes are equidistant. So this is the first experimental result. Second, this is bright, dark, bright, dark, bright, which means that they are alternating, and there aren't two consecutive bright or two consecutive dark. Okay? Now, the last idea, I still have two ideas, sorry. Interfringe distance. What do you mean by interfringe distance? Interfringe distance. It is better to use the black. Interfringe distance. Okay, we are going to represent it by I. Definition: it is the distance between two consecutive bright and dark fringes. two consecutive fringes of same nature. It is better to write this: consecutive fringes of same between the centers. Okay, always we are talking about the centers. It is the distance between the centers of two consecutive fringes of same nature. Okay, يعني what does this mean? This means it is the distance between two consecutive bright or two consecutive dark. يعني for example, this is bright, this is bright, so this is the distance I. This is bright, this is bright, consecutive bright, this is I. Also, it is the distance between two consecutive dark. يعني this is dark, consecutive, this is I, or this is I. This is what do mean by two consecutive fringes of same nature. Okay? Right. How to find I? Let's see. Also here, we are talking in vacuum and in a medium. Let's see. In vacuum or air, in vacuum or air, what do you have? Notice here, I, if I take K0, K1, so I can write I equal X1 minus X0. Okay, this is I. The second I here, it is what? It is X2 minus X1. I equal X2 minus X1. If I take the third I equal X3 minus X2. But whenever we want to prove a formula, it should be proved in general. I can't take one of this to calculate I. So, in a general, as you notice here, in general, notice I 1 0 1 1 2 2 3. So in general I can write x k plus 1 minus xk. This is I in the general form. 0 1, so 1 is in more than 0 by 1. 1 2, 2 more than 1 by 1. 2 3, 3 more than 2 by 1. So in general, this is a fringe of order k, which is any one. Suppose this is 1, has order k. We are talking about bright fringes. So from here, I can deduce that if I choose any center of a bright fringe, it will be of order k, and the consecutive one, this is xk, and the consecutive one is xk plus 1. Okay? So I equal xk plus 1 minus xk. Sorry, this is formula. Okay, formula. شوفت هيدي formula of I, whether in vacuum or air or a medium, idea in general, okay? In general. And this is applied for bright and dark fringes. Similarly for dark fringes, this will be k prime plus 1 minus x k prime, okay? Right, now let's find this formula of I. For a bright fringes, okay, idea in vacuum or air. You know, since it's a bright, yani xk equal k d lambda over a. Okay, k belong to z. Now, xk plus 1, what does this mean? I replace k by k plus 1, k plus 1, you get d lambda over a. So I equal xk plus 1 minus xk gives you k plus 1 d lambda over a minus k d lambda over a. Expand. You notice and k d lambda over a cancels with k d lambda over k, and you get d lambda over a. Okay? This is d lambda over a. In a medium, what happens? Same, d constant, a constant, lambda changes to lambda prime. So I becomes I prime. So this implies I can write in the medium I prime equal d lambda prime over a. But lambda prime is equal lambda over a. This should be over n. This should be proved. Yani this implies I prime equal d lambda over n a. Okay? Notice here d lambda over a is I. Yani this implies I prime equal I over n to be proved. You should prove it first to be proved. Okay? N greater than 1 also. Yani this implies I prime smaller than I, which means that the fringes become closer to each other. Okay? Let's see for dark fringes. So, the same for dark fringes in vacuum or air, this will be changed, okay? So you get here x equal to k prime plus 1 d lambda over 2a. K prime belongs to z. This is xk of order or xk prime. What about order k prime plus 1 gives you 2. Instead of k prime, I replace k prime plus 1 because this is the order plus 1 d lambda over 2a. So you get here 2k prime, 2k prime plus 2 plus 1 plus 3 d lambda over 2a. Okay? Subtract them So you get I, this minus this, 2k prime plus 3 d lambda over 2a minus 2k prime plus 1 d lambda over 2a. So you get I equal, expand, you get the same result, and this is expected because they are equidistant, okay, from each other. Also, for a medium, you get the same formula because this is the same for the bright and the dark, and by same proof, you get I prime I over n also for the dark fringes, okay? فإذن it is not necessary to repeat it. So, in a medium, you get I prime equal I over n. But I like to give a small exercise about the variation of I with lambda, okay? Or note here, note. Draw that exercise, small exercise. Draw the graph of I versus lambda. Okay. A. B. Describe the obtained graph. Okay. C. Suppose A is given. Use the slope to find D of the distance of the screen. Let's look at I. Solution here. As you see, I is equal D over A lambda. Okay? First of all, in order to draw the graph, you should start with what? As I told you, you should start with the domain of definition. Don't forget. And here the domain of definition is not from 0 to infinity. This is not mathematics. This is physics. You know, interference here called interference of light. Okay? So this is lambda of light, whose domain of definition in vacuum, as you said, lambda is between 0.4 micrometer 0.8 micrometer. So this is in vacuum or air. Okay? Or air. So there is minimum and maximum. The minimum, هيدي violet. So I violet تعطيني D over A lambda violet. Okay? Well, maximum is I red, which gives me D over A lambda red. And this is the first. Okay, this is the first thing that you should know, that I here, there is minimum and maximum for I. Yani, if I plot a table here, this is I. أو lambda versus I, lambda versus I. If I give you several lambdas, several lights between these, suppose I give you between violet and red several lambdas, okay? So you have here lambda 1, lambda 2, lambda 3. You should take care about the minimum. Lambda violet gives me I minimum. Lambda red, which is the maximum, gives me I maximum. This is I1, I2, I3. فإذن, the most important is the domain of definition, okay? Domain of definition. The second here, if you take care about the formula, what is the form of the formula? Okay, as you see, it is very simple. It is in the form of, فإذن, I write I equal D over A lambda is in the form what? I equal S lambda, where S equal slope equal D over A. Okay? Yani, what does this mean? This is in the form Y equal AX, which is the equation of a straight line passing through the origin. Okay, so I need, it is sufficient to take 2 points, because equation of a straight line. So this is lambda, this is I. هيدي lambda violet gives me I minimum, هيدي I minimum, and you get lambda red gives me what? I red. So these are the 2 points, 1, 2. If I join them, I get what? I get is an increasing segment of a slope D over A. Okay, part B describes the obtained graph. Obtain the graph. The graph is an increasing segment that passes through the origin if I extrapolate it, okay? So, what do I mean by this? This means that if I expand this is maximum, okay? If I extrapolate this line, it passes through the origin, okay? But in reality, it doesn't pass because lambda less than violet, I will be in the ultraviolet region, which is invisible, okay? Because this, I didn't include this segment here. Type, last part, suppose A is given. You have A, okay? Use the slope to find D. I am going to use it to find D. So part C here. Part C, I want to find D using the slope. We said that the slope is equal D over A. Okay, this is given. I want D. Type. I have, this is a segment. I can find the slope from the segment. So S equal what? I maximum minus I minimum over lambda violet, lambda red minus lambda violet. Okay? The slope here without unit, if this is millimeter, this should be in millimeter. Okay? When I find the slope from the graph, cross multiply, you get D equal SA using the slope. Okay? Right. The last point I want to say here. Does you have always interference? Do you have always interference? Let's see. Let's see. This is a lamp, this is a lamp. These are two sources of light. And the light spreads from them all over the room. This one and this one. So the beams of these two sources superpose. But if you look at the floor, you won't see interference fringes. Okay? Type why? Why I don't see it? This means that there are conditions for interference, and not any sources of light produce interference. Okay, although they superpose. Here you have superposition of beams, but no interference. The interference is manifested by the alternating bright and dark fringes. So there are conditions of interference. Okay, you have two conditions. أول condition, the first condition, the two sources of light must be synchronous. Okay, شو يعني synchronous؟ يعني this implies same frequency nu. Okay, يعني look here, light from S1, from S2, the frequency of light leaving S1 must be equal to the same frequency of light leaving S2. يعني this means you should have same color. Okay? يعني what does this mean? يعني dark red interfere with dark red. Okay? يعني هون red will interfere with dark red with same lambda. Okay? يعني red doesn't interfere or doesn't superpose with another red, but to make interference fringes, dark red of specific lambda should superpose with dark red of same lambda. يعني dark violet won't give interference fringes. They superpose without causing interference, and so on. Okay, so this is the first condition. Okay, look here, but the frequency lambda, what is it equal to? Lambda, if we are in vacuum or in air, the speed is c over nu. If the two sources have same frequencies, this implies same lambda. يعني this implies the light should be monochromatic, should be monochromatic. Okay? The second condition Monochromatic يعني same frequency, same lambda, okay? The second condition, the sources should be coherent, should be coherent. What do you mean by coherent? Coherent means S1 and S2 should be in phase, should be in phase, or of constant phase difference, constant phase difference, okay? Notice here, look here, if this is source S, the two waves reaching S1 and S2 will leave S at the same time. And because they cover same distance, they will reach S1 and S2 in phase. Okay? So they will be emitted from S1 and S2 in phase. And so they produce, if they are monochromatic, they produce interference fringes. Okay? هلا الphase difference constant depends. For example, this is S1, this is S2. If this is source S, as you see here, light covers distance D2 more than distance D1. So there is here possibility for the light leaving S1 and S2 not to be in phase. Okay? If the phase difference of the light here at S1 and S2, phase difference is equal to constant, then they will interfere. Okay? And always, when you have coherent sources and monochromatic sources at the same time, the slits should receive light from the same source. Okay? This is very important. فإذن, for these two conditions to be satisfied, S1 and S2 should receive light from the same source. Okay? And this is what Young's experiment satisfy. S1 and S2 receives light from the same laser light. Good luck. This is the end of this session, and good luck.